Let's look at some special case triangles when we're finding side lengths. Now you remember earlier we worked really hard with things like law of sines and law of cosines to figure out some unknown variables in a triangle. And we could go through all the work and say, okay, well I know that if that's 90 and that's 60, that must be 30. And I have an opposite pair here, and I have an opposite pair here, and I can do law of sines and do all this work. But whenever we have a 30, 60, 90 triangle, 30, 60, 90, it follows a nice little pattern. So I'm just going to draw out a basic template here of what this looks like. Put our 60 down there, our 30 up here, and our 90 right here. If this side is length x, then the long side is going to be twice as long, 2x let's say. And the medium length side is going to be x times the square root of 3. And if you're not sure why that maybe makes sense, if you think of the Pythagorean theorem, let's get rid of the x and just pretend that it's 1, 2, and square root 3 over here. If you were to square them all, if you were to take 1 squared, that would be 1, plus root 3 squared, which is 3, equals 2 squared, which is 4. And 1 plus 3 does equal 4. So it does follow the Pythagorean theorem and happens to work out quite nicely like this. So using that basic pattern now, we can look at the triangle we have and say, whatever y is, this is going to be twice as big. Or when working in reverse, if whatever 10 is here, y is going to be half as big, because we know that the longest side and the shortest side have a 2-to-1 ratio. So I can go ahead and replace this y and say y is equal to 5. And generally it's always best to get your shortest side first, because everything kind of depends on that shortest side. Now that I know that y is equal to 5, I can say x is 5 times the square root of 3. So I have 5 times square root of 3, and 5 times 2, which we know is 10. So you can do those types of special case problems. One other type of special triangle is the 45, 45, 90 triangle. And whenever you have that, you always have this pattern. If this side is x, this side is going to be exactly the same. And this side is going to be x times the square root of 2. If you prefer concrete numbers, we could say that this side is square root of 2, and these sides are each 1. And again, like before, if you do Pythagorean theorem, 1 squared plus 1 squared is 2. And if you square root all of those, you get 1, 1, and square root of 2. So it does work with the Pythagorean theorem. So let's go back to our original triangle here. One of our short sides is a 9, which means that our other short side must also be 9. And our long side must be 9 times the square root of 2. Now again, it's important when you look at these types of problems to not get too caught up in shortcuts. Shortcuts can be dangerous. But do know that if you see these triangles, these 30, 60, 90s, or these 45, 45, 90s, it can save you a lot of time to take the shortcut. So I want you to go ahead and practice with a few of these.